Today I will be going over Target 9 homework. Target 9 homework is on solving rational functions. Remember, the first thing we're going to have to do on all of these problems is get a common denominator throughout the entire problem. When I look at number 1, I notice I have a common denominator of x squared in two of my fractions, but I only have x in my third. So I'm going to multiply this middle fraction by x over x so I can have the same denominator for all three fractions. Remember, when we multiply our fractions, you always have to multiply the top and the bottom. Once we have a common denominator for everything, we can just concentrate on our numerator. So we're going to rewrite this as just 1 minus 3x equals 4. Subtract 1 from both sides, negative 3x equals 3, and divide by negative 3, and x equals negative 1. We do always need to check for extraneous solutions, so you want to make sure that if you plug negative 1 into the denominators of your original function, that it doesn't equal 0. Negative 1 wouldn't make x squared or x equal to 0, so we are good with negative 1 as our solution. On number 2, I see that I have 3v squared on two of my fractions, but my last one is just v squared, so I'm going to multiply the top and the bottom by 3. So I have 1 over 3v squared equals 5v plus 10 over 3v squared minus 3 over 3v squared. Again, I have all the denominators equal to one another, so I'm just going to work on solving my numerator. Combining my like terms, I have 1 equals 5v plus 7. I'm going to subtract 7 from both sides, and I have negative 6 equals 5v. Divide both sides by 5, and v equals a negative 6/5. Again, check and make sure that won't make any of our denominators equal to 0, so our answer is good at negative 6/5. Okay, looking at number 3, I don't have any fractions with a common denominator. I do notice, at least to start with, I do have x squared in all my denominators, so the only thing I need to worry about is that coefficient, our number in front. Between 1, 2, and 4, my least common denominator I'm going to have to use is 4. So I'm going to multiply this first fraction by 4 over 4. I'll multiply the second one by 2 to get that 4 in the denominator. And I'm going to leave that third one as 4x squared because that will be the common denominator we use. When I multiply by 4, I get 8 over 4x squared. When we multiply the second fraction, remember we have to distribute that 2. So I get 2x plus 10 over 4x squared. Minus, we didn't have to do anything to that last fraction, so 1 over 4x squared. My denominators are all the same, so I'm going to use my equation setting my numerators equal to each other. So 8 equals 2x plus 10 minus 1. Simplify that right-hand side. 8 equals 2x plus 9. Subtract 9 from both sides, and negative 1 equals 2x. Dividing by 2, I get x equals negative 1/2. Again, that solution works. It wouldn't make any of our denominators equal to 0. On number 4, I notice that my first two fractions have a common denominator, but my third one does not. We always want to try to factor these to find out what that common denominator is. When I factor this first denominator, I notice I have a greatest common factor, so I'm going to pull 2 out. Then I'm left with v squared minus 3v minus 4. On this one, I can actually stop factoring there because I notice once I pull that 2 out, what I'm left with on the inside here is the exact same as my denominator on the right. So all I need to do to that denominator on the right is multiply by that missing 2 that it doesn't have on the outside. So we factored that 2 out. I could factor that 2 out of my second one and have the same thing, but I need to multiply this third fraction by 2 over 2. So I'm going to have v minus 5 over 2v squared minus 3v minus 4 minus 1 over 2v squared minus 3v minus 4, and that equals 2v over 2v squared minus 3v minus 4. Our denominators are the same, so we'll just use our numerators now. I have v minus 5 minus 1 equals 2v. So v minus 6 equals 2v. Subtract v, and v equals negative 6. Make sure you plug negative 6 into the denominator. When I plug negative 6, I don't get 0. So negative 6 is a solution. Remember, if the denominator was equal to 0, then the negative 6 could not be a solution. Okay, so number 5, again, I need to look for a common denominator. Unfortunately, on this one, I don't have any common throughout my 3 fractions. So the first thing I'm going to do is I'm going to factor my first denominator here. I'm looking for what multiplies to 3 and what adds to my b term, so adds to negative 4. Since my a value is 1, I know I can use my shortcut method. The two numbers that multiply to a positive 3 and add to a negative 4 are going to be negative 3 and negative 1. Well, that works out pretty nicely because I notice my other 2 fractions, those are the 2 denominators that I have. So in the second fraction, I have x minus 3, but I'm missing that x minus 1. So I'm going to multiply my second fraction by x minus 1 over x minus 1. My third fraction, I notice that that has x minus 1 in common with my first fraction, but it doesn't have the x minus 3 that those 2 fractions have. So I'm going to multiply that third one by x minus 3. Okay. So when I write this out, my first fraction didn't change, so I have x plus 2 over x minus 3, x minus 1. My second fraction, I need to remember to distribute that 2, so I have 2x minus 2 over x minus 3, x minus 1. And my last fraction, remembering to distribute that 4, I have 4x minus 12 over x minus 3, x minus 1. So now all my denominators are the same, so I'm just going to look at my numerator. So I have x plus 2. We have to be careful because we have this subtraction sign here, so remember we have to distribute that negative to everything on top of that second fraction. So I have minus 2x plus 2 equals 4x minus 12. Combining my like terms, x minus 2x gives me negative x. 2 plus 2 gives me a 4. That equals 4x minus 12. Add x over to both sides. 4 equals 5x minus 12. So then I'm going to add 12 to both sides, and 16 equals 5x. Divide both sides by 5, and x equals 16 fifths. When I plug that into my denominators, it won't make any of them equal to 0, so it's not an extraneous solution. Okay, last but not least, we have number 6 here. Let's move this over a little bit so we have more room. Correct. Okay, so on number 6, again, the first thing I need to do is find my common denominator. We have that 1 in there, so no 1 is over 1. Remember, whenever we have a whole number or something without a denominator, it's always going to be over 1. So first thing I want to do is I'm going to factor that third fraction's denominator. So I'm looking for 2 numbers that multiply to 25, and those same 2 numbers have to add to that negative 10. So it's going to be negative 5 and negative 5. So this factors to x minus 5, x minus 5. Now, when I look at my first fraction there, 1 over x minus 5, it has x minus 5, but it only has one of them. I have to have 2, so I'm going to multiply this first fraction by x minus 5 over x minus 5. My second fraction of 1 over 1 is missing my entire denominator. So I'm going to have to multiply it by x minus 5 over x minus 5 twice so that it has the same denominator as the other two. I'm going to move this down here so I have enough work. So my first fraction, 1 times x minus 5, gives me x minus 5 over x minus 5, x minus 5. My second fraction, I'm going to have plus, and then I have x minus 5 times x minus 5, so we're going to distribute that out. When I distribute that, I get x squared minus 10x plus 25 over x minus 5, x minus 5. Remember, we never have to distribute our denominators out because we know they're all going to cancel. The right-hand side had my common denominator already, so I didn't need to do anything to it. Now I can set my numerators equal to each other, so x minus 5 plus x squared minus 10x plus 25 equals x minus 4. Sorry, switch that 4 to a 5 there. Okay. Now, I have a quadratic here, so remember with our quadratics, we always want to set them equal to 0. This way we can either try to solve them by factoring, or we can solve with the quadratic formula. So first thing, let's combine our like terms here. So I have x squared, x minus 10x gives me a negative 9x. Negative 5 plus 25 gives me plus 20 equals x minus 4. I'm going to subtract x, and I'm going to add 4 so that it can equal 0. So x squared minus 10x plus 24 equals 0. Now I'm looking for two numbers that multiply to 24, and those two numbers need to add to negative 10. So I have negative 6 and negative 4. So that factors then to x minus 6 and x minus 4. When I set those two equal to 0, I get x equals 6, and I get x equals 4. Again, we need to check to make sure that those numbers are not going to make my denominator equal to 0. If I plug 6 or if I plug in 4, neither of them will equal 0, so both of them are solutions. If you have any questions, please come on in.